Hello to everyone just joining. Hello and welcome. We will just give everyone a minute to join. It's gonna take probably a little while, so just please bear with us. But hello and welcome to our session. Some people are still joining, but in general, it seems that most people that wanted to join are already here. And since we sort of need to be precise on time, I think it's fair to start. So hello and welcome everyone. My name is František Ficek, and I have the honor of being the YSPC, the Young Scientific Program Committee member for this seminar series on using sanitation system for climate change mitigation and adaptation. This is a very exciting topic, as well as this the whole topic of this year's World Water Week, Water for Climate Action. And very excited that we have the honor to kickstart our three-part seminar series. So for everyone joining, we have two more sessions connected to this seminar. One that is hybrid online and on-site tomorrow at 2 p.m. Stockholm time, and then one just on-site at 11 p.m. on Wednesday. 11 a.m. Wednesday morning. So in case you're in Stockholm, please come to join that one, or if you're also online, you can join the one tomorrow. Now, a little bit of housekeeping. In this session that is focused on the science behind sanitation and climate change, you will mostly hear our presentations from our distinguished speakers. But of course, we want to also hear from you. So in case you have any questions during these presentations, feel free to drop them into the chat, and either our speakers can directly engage with them in the chat, or we will answer them during a Q&A session that we have in the middle of the session. Or then also during this Q&A, there is a little button in which you can ask that for you to be unmuted by our lovely administrators. So if you sort of request this, you will be unmuted, and then you will be able to ask your question directly. Otherwise, yes, you will be muted during the whole session. Otherwise, of course, this could get very messy very quickly. My colleague Leslie just asked you to introduce yourself in the chat. So please, if you could do that, just write who you are and where you're from, or maybe also what interested you, or why you joined this session. You would definitely like to hear that. And I think that I don't need to speak for any longer, and I can give the opening floor to our amazing keynote speaker, John Lane, the founder of WINS, the Water Initiative for Net Zero, and also the chair of the Scientific Program Committee here at the World Water Week. So, John, over to you. So I will ask Linnea to allow John to unmute himself.
Okay, great. Yeah, thanks very much, František. As František mentioned, I'm speaking here in my capacity as the chair of WINS, the Water Initiative for Net Zero. You've read in the online program that this seminar is going to provide foundational evidence about sanitation, both in mitigation and in adaptation. And of course, both those aspects are important, and they're strongly interdependent, as culminates in the concept of climate resilient sanitation that my colleagues will be talking about later. The following speakers are going to present you with the science and the data. So in these few words, I just want to concentrate mainly on mitigation, because until now, water people have given it less attention than adaptation. And I want to encourage you and motivate you to continue your work in sanitation to reduce greenhouse gas emissions, because that's WINS's main concern. The problem of global heating is so huge and so urgent that everybody in all walks of life must do what they can to solve it. We all have a choice. We can deny the problem and bury our heads, or we can face up to it and act to stop global heating now. The planet's remaining carbon budget to meet the international target of 1.5 centigrade is going to be used up in the next 2 years at the current rate of emissions. So let's reduce the rate of emissions. What can water people do? Well, it turns out that we can do a lot, because water accounts for 6 to 8% of global greenhouse gas emissions. That's much more than either aviation or shipping, two sectors that receive huge attention from the media and politicians, while water is largely ignored by them. If water were a country, it would be the 4th biggest emitter in the world. Happily, we have plenty of proven solutions that can reduce greenhouse gas emissions in many water-related areas. These are my key points about water and sanitation for mitigation. Firstly, that we're communicating messages from the water professionals into the political and public arena. Secondly, we're not holding our hands out and saying, please give us money, our work is important. We're offering our work as a tool for others to achieve their climate aims. And thirdly, our messages are positive and helpful ones, backed up by good science. The 3 big water-related mitigation topics are agriculture, chiefly rice growing, nature, particularly peatland management, and sanitation. And this year at World Water Week, there are SIWI seminars on both of those other topics, in addition to this seminar about sanitation. My colleagues are going to present much more about it in a moment, so let me just say this. Human excreta give off a huge amount of methane, which is a particularly potent greenhouse gas. We now understand that the actions that we can take to rapidly and significantly reduce the methane turn out to be the very same actions that improve the sanitation services for the users. So as a sanitation professional myself, I find it really exciting that we can simultaneously improve people's lives and reduce greenhouse gas emissions. And that's a real win-win. I thank each and every one of you for attending this seminar. You are pioneers. While many water people work on adaptation, very few work on mitigation. I encourage you all to be involved in this great work and to get a lot out of the remainder of this particular seminar. Thank you very much.
Perfect. Thank you so much, John, for your remarks. And yes, this is truly a very novel and innovative topic. And again, this just makes me super proud to be here in this session, in this room with all of you. Now, without further ado, I would like to pass the word towards my lovely colleague Stan Drabble from Water Sanitation for Urban Populations, who will give his presentation, Sanitation and Adaptation. Sam, as I mentioned, I'm gonna share your slides, so please just tell me whenever you want me to move to the next one. So over to you, Sam, and I'll share my screen.
Brilliant. Thank you, Franciszek. And it's a privilege to be able to participate in this session. And my role here is to give an overview of the current evidence base around sanitation and adaptation. And I'm really speaking here on behalf of the Climate Resilient Sanitation Coalition. Yeah, we can go to the next slide, please. So beginning with really important context on the status of sanitation globally. And we hear the term sanitation crisis used in current discourse, and that is quite accurate, as you see borne out from these statistics. So over 40% of the global population still without access to safely managed sanitation. That's really, when you reflect on it, an incredible statistic, and only 56% of household wastewater flows are safely treated. And if sanitation is poorly managed, we know that has devastating impacts on individuals, on societies, on whole environmental ecosystems. And we can begin there with the health impacts. Again, these statistics you may have seen before, but they really bear some reflection upon over 500,000 deaths attributed annually to poor sanitation. Nearly 2 billion people have fecally contaminated water supply. We know that there is increased incidence of cholera with recent outbreaks in multiple countries. There are downstream health risks that flow from poorly managed sanitation, for example, for farmers. And then there are wider impacts, economic impacts from reduced livelihoods, social impacts, of course, particularly for women and girls. That is an enormously important aspect of this challenge. Environmental pollution, reduced community resilience, born from areas such as food security, greenhouse gas emissions, which Barbara will come on to. I won't address that in this presentation, but all of this leads to reduced also overall societal resilience to climate change. Next slide. And here I'm presenting the links between sanitation and climate change. And this has been developed again by the Climate Resilient Sanitation Coalition. They're really useful graphics. So on the left-hand side, you see the vicious cycle of non-climate resilient sanitation. In essence, poorly managed sanitation leads to increased greenhouse gas emissions, leading to extreme climate events, causing sanitation services to fail, and failed services then lead to poorly managed sanitation, and because of that poor management, more emissions. By contrast, the right-hand side is what we're working towards, which is a virtuous cycle of climate resilient sanitation, safely managed, adaptive, risk-aware sanitation services, leading to reduced emissions, fewer climate events, fewer sanitation system failures, greater access to safely managed climate resilient sanitation. Next slide, please. Now here we're presenting a synthesis of the evidence base around known impacts of climate change on sanitation systems. And there's been a lot of research already done in this area by, for example, Guy Howard at University of Bristol and many others. And that has identified 5 key hazards that we need to keep front of mind in terms of their impact on sanitation services. So first of all, flooding. We know that flooding can lead to a risk of overflow of septage from pit latrines and septic tanks. I should say across all of these areas, the empirical evidence base around these connections is growing all the time. So there is research forthcoming from University of Technology, Sydney, which really fleshes out these linkages between flooding and sanitation systems. Drought and water scarcity, we know has an impact on operations and maintenance and the functionality of sanitation systems, as well as posing risks for groundwater contamination. Sea level rise and extreme storms, of course, both can have an immense impact on sanitation systems in coastal areas, and then extreme temperatures, which exacerbate all of these hazards and also have a specific impact around biological treatment. Next. And here you see some illustrations of these impacts. So if we take drought and water scarcity, you can see that leads to poor flush toilets becoming dysfunctional. Ultimately, there may then be slippage and people returning to open defecation, but also sewage systems can be impacted and can become blocked. When we look at storms, flooding and sea level rise, I mentioned overflow from pit latrines and septic tanks. Pit latrines are also liable to collapse. Rising sea levels can inundate wastewater plants, and a number of climate hazards could lead to displacement and people losing access to safely managed sanitation. Next. Now here we're looking at how we quantify the risk from these climate hazards, and there is an equation which we'll come back to throughout this seminar series for those who are able to join other sessions, that is really useful to keep in mind. It's the equation used by the Intergovernmental Panel on Climate Change and by Green Climate Fund, which is risk equals hazards times vulnerability times exposure. So we've just presented the hazards, but we also need to understand who is exposed to those hazards. For example, residents of a coastal city are likely to be exposed to rising sea levels, but also then very importantly, who is vulnerable. So you can be exposed but not vulnerable because your sanitation systems are climate resilient. So the focus of these efforts is understanding who is vulnerable, in what ways, and what interventions can follow from that to address that. Next. And in terms of identifying priority populations, again, this graphic developed by the coalition is really useful. So this is segmenting populations and ultimately leading to priority populations for adaptation activity. So on the left, segment A relates to people who are without access to safely managed sanitation but are not climate vulnerable. Segment B is populations who are climate vulnerable and have no access currently to safely managed sanitation. Segment C are climate vulnerable, do have safely managed sanitation, but that needs to be retrofitted to become climate resilient. And segment D do have access to safely managed sanitation but are not climate vulnerable. So where does that leave us? Segments B and C is where we need to focus. Essentially, those populations who are climate vulnerable and do not have safely managed sanitation, and those who are climate vulnerable and do, but that needs to be made climate resilient. Next. And this graphic is, or these maps are showing what that looks like played out at the global level. So this is data that is mapping sanitation access alongside climate vulnerability. And over 40% of the global population are known to be climate vulnerable. And what these maps show is there is very strong overlap between that climate vulnerability and the regions that have the lowest access currently to safely managed sanitation. So this is an area where UNICEF and others are really focused, overlaying low access with climate vulnerability to focus interventions on adaptation. Next. This slide is then looking at how we can look at risks at a more localized level through climate risk assessments, and we'll share more information around risk assessments as we move through this seminar series. But on the left-hand side here, you see the hazards that I presented earlier, and on the right is a table from a paper led by Leonie Hyde-Smith, which is mapping climate change impacts on urban sanitation, so sanitation failure modes, looking across the sanitation service chain. So again, that evidence exists, that analysis exists, looking at the more specific impacts across the sanitation service chain from these hazards. Next. And here you're seeing some of the potential interventions. Now, we're going to go into this in more detail in tomorrow's session, which again is hybrid, so you can join online. But just to take a step back around adaptation and what exactly do we mean by that, and what does that mean for intervention? So adaptation involves anticipating impacts, identifying response measures, so infrastructures, services and behaviours are more resistant to hazards in current and future climate scenarios. And when we keep that definition in mind, there are a range of interventions which we have a fairly strong basis, although we need to continue producing more evidence that those are effective responses. And I want to underline it's not only infrastructure, services and behaviours are also a key part of this. Climate impacts can affect the potential of service providers to deliver services. They can affect the ability of communities and residents to practice behaviours, all of which contribute to sustained access to safely managed sanitation. Next. And this is my final slide, which is to underline that sanitation adaptations can be transformative. Now, again, this is an ongoing area of research. Juliette Willis, for example, at University of Technology, Sydney, doing research now around what transformative adaptation means in practice and as well as in theory. And here you see that sanitation has very strong known interlinkages with other sectors. So we know that through safe treatment and fecal sludge byproducts, for example, they can contribute to energy, to food security. The connections between sanitation and health are very real. The evidence base is growing all the time in that area, and sanitation can mitigate the impacts of water scarcity born from climate change, for example, by safe reuse of wastewater. Okay, next slide. Yeah, so I'll wrap up there. This is just to, I think there's a link which we'll try and put into the chat. It's gone from the slides. But I wanted to just plug here again the Climate Resilient Sanitation Coalition. So all of the analysis I've just presented, developed by that coalition. Work is ongoing now from the coalition to synthesize the current resources, and all of those will be made available and updated on the Susanna website. So I'll see if we can put that link into the chat, but really just to drive you to look at those resources on the Susanna website. They're publicly available. There's a lot of research in this area. I haven't cited it all, but I really want to emphasize that you can access it through Susanna. Okay, that's all from me. Thank you.
Perfect.
Yes,
Thank you.
You go ahead.
Yes, thank you so much. You can mute yourself, Barbara, for a moment. Perfect. Thank you so much. And thank you so much, Sam, for giving us this amazing overview that definitely prepare us very well for our next presentation and for our next speaker. And I see that we already have the missing link in the comments, it seems like. So thank you so much, Andres, for putting it there. And so without any further ado, I want to give the floor to Barbara Evans, who's going to take us really into the scientific background that we really need to really deeply understand the issues of this seminar. So Barbara, over to you.
Thanks so much. To stop the timer. So I'm going to give you a little kind of lightning tour through some of the scientific issues. There's a huge amount of science. I'm not going to give it to you all, but like Sam, I'll try and give you some pointers to some resources. Of course, now I can't get my screen to progress. Come on. There we go. So the first thing just to say on the science side, we have to always ask the question, are emissions from sanitation important? As John said, yes, they are. We're pretty sure that they are accountable for a measurable fraction of anthropogenic carbon. We don't know exactly how much, but none of these numbers are small numbers. There's another reason why it's really important, and that's because we'll have to deal with human excreta forever. You know, humans will be here and will be excreting forever, and human excreta will be producing methane forever. So as other sectors get better at reducing emissions, the significance of sanitation will, even if it stays the same, the significance will rise. And the other thing, just to really re-emphasize the point that John made, is that reducing emissions would be a characteristic of improved management of sanitation. One thing we do know for sure is that a lot of the emissions that we're currently seeing are due to mismanagement of waste, which gets into the environment, particularly into the aquatic environment. So solving that problem would be a win-win. I've decided to organize this presentation around 3 challenges in the science. There's a lot of science, but 3 things to sort of point out as important areas where the Climate Resilient Sanitation Coalition is going to be playing a really important role. One is about a standard categorization of emissions from sanitation. On the science side, we've been kind of working towards this, but it's something that we really need to make sure we've embedded in the sector. Another point to make is that we don't know what's really going on inside sanitation systems, specifically relating to the production of methane and nitrous oxide. And that's why right now is a very important period of live science, because we need to understand this more. Unfortunately, that leads me to my third challenge, which is that measuring emissions from sanitation is not simple. And I'm just going to talk a little bit about those 3 points. So first to the categorization question, and this I hope will be useful to all of you who engage with people on the climate side on this topic. One set of definitions that we need to be very aware of are the World Business Council categories, which divide emissions into what are called Scope 1, Scope 2, and Scope 3 emissions. There are some other scopes as well, but these are the 3 which are relevant to us. Scope 1 are greenhouse gas emissions associated with the normal operation of a system. So, you know, energy generation, chemical processes, transportation of waste. Scope 2 are emissions from the imports of power into a system. And Scope 3 are other indirect emissions, and we'll come to what those are, but essentially relating to things which happen upstream or downstream of a process. I'm going to talk about this by looking at what we normally call in our industry on-site systems, household systems, small community systems, places where you essentially collect some waste in a box. I will refer you to the annex which we prepared for the Green Climate Fund for more details on this, and that will be covered in tomorrow's session, I think, right, Sam? But just to give you an idea here, so Scope 1 emissions, we're talking about what we call direct and fugitive emissions. So that's all of the methane and nitrous oxides that's being produced in the system, plus some CO2 actually that is produced in the system. And we see that that's produced at the containment level, at emptying and transport, at treatment, but also importantly produced when we dispose of the end product of a sanitation system, either in a managed or unmanaged way in the aquatic environment or on land. A point to make here is that I would argue that for on-site systems, the energy that we use for trucking is not a Scope 2 emission, it's a Scope 1 emission. It's internal to our industry. We can't run those systems without that transportation element. And that's a very important, and the same is true for trucking sludges away from treatment plants. Those are internal to our industry. And I think it's really important that we talk about that clearly. One of the reasons for that is that the way you attract funding for Scope 1 and Scope 2 emissions is different. So understanding those emissions and that they fit within Scope 1 is really important. I think it's also important to say that the science on direct emissions from land and water discharges is very, very undeveloped at the moment, and it's an important area. This is Scope 2 emissions, primarily the energy that we use in treatment processes, and Scope 3 emissions, which are embedded carbon, which we understand pretty well, and another area which we don't understand well, which is essentially the value of the byproducts or products of sanitation when we reuse them downstream and how we can substitute out other inputs. For systems where we have sewers, we have exactly the same categorization issues. I don't want to go into it in detail here because I'm trying to keep the presentation short, but again, I defer you to the annex. Does it matter? It might when we think about carbon credits, and it does because all these categories are important and we need to make sure that we're prioritizing research across the board. The second challenge is we don't know what's going on inside systems. The IPCC uses a very simple, essentially says there are types of systems, we multiply that by the number of users, and we create an emission profile for each type of system. We use very simple terms like simple pit, septic tank, but we're all sanitation people, we know it's not really like that. And the IPCC is generally only counting direct emissions from static systems. But what we know is that our systems are actually very dynamic, and we need to understand both these direct and operational emissions in our dynamic systems. The other thing is that this emission profile is based on some very simplistic equations. And here again, we find that we don't really know what's going on. So to give you an example, here are two equations for emissions from domestic wastewater at the top and on-site sanitation at the bottom. In both cases, emissions are a product of population, the nature of the sludge or wastewater, specifically the organic content inside the sludge and wastewater, and the way in which the sludge and the wastewater gives up its gases. We know that there are several physical characteristics. Sometimes we know a little bit about that. We know about total organic content or BOD, but in both cases, there's this magic thing, you can see it here, called the emission factor. And that for most people is a bit of a black box. The emission factor is a product of something called the maximum methane production capacity, B0, and a methane correction factor. We know that these change in different contexts. Currently, the IPCC has some standard values for these, and they're based on a tiny number of studies in very specific systems. I cannot emphasize enough how little we know about what really happens inside systems. The IPCC estimates, or any estimates that we make that rely entirely on IPCC assumptions, are extremely uncertain. And we have to be very careful that we articulate that when we're using these data and talking to policymakers. There's lots of work going on to improve our understanding of what B0 really is under different circumstances and how rapidly the potential methane inside fecal wastes and wastewaters are converted into methane, depending on the operating conditions of real systems. There will be data coming out later this year from the SCARE project and the EMISI project covering 5 countries. Those studies rely on measurement, and that brings me to my third problem. Measurement is really difficult. It's difficult because A, we don't actually describe systems very well. So if you are getting involved in measurement of emissions, please, please, please make sure that you are using really accurate technical descriptors of the systems where you measure, because we need to be able to work out what we measure in the field and how it relates to the general conditions of sanitation systems. And I also would like to emphasize that the act of measuring is quite tricky. Methane and nitrous oxide are very difficult gases to handle. So just draw your attention to lots of work that's going on to try and develop some standard methods and tools for measurement. These are in on-site systems. Here's some work going on in a wastewater treatment plant. So Are emissions from sanitation important? Scientifically, yes, and it really matters, but we do still have three scientific challenges. And I really want this community, I think, to keep alive and keep sharing experiences and making sure that we develop a really strong scientific basis for any policy claims that we make in the future. Back to you. Oh, lost my cursor, sorry.
Give me a second to mute yourself. You a second to mute yourself. Thank you. Thank you so much, Barbara, for this amazing deep dive into the scientific background. And since we're sort of right on time, I'll give the floor directly to my colleague Andres Masu Gonzalez from WaterAid and Pratibha Podel from Kathmandu University, who also work on the SCARE project that Barbara just mentioned. So we have a nice connection here. And right now we're going to do a little more case study deep dive into sanitation climate in Nepal. So Pratibha and Andres, over to you.
Thank you so much. Hi, everyone. I'm Pratibha Podel from Kathmandu University. And following 10 minutes, myself and Andres will be presenting the findings from our collaborative project between WaterAid UK and Kathmandu University, which is all about estimating greenhouse gas emissions from Lahan municipality in Nepal. Next, please. Next slide, please. Okay. So as Professor Evans already mentioned, all the sciences behind the greenhouse gas emissions. So I'm not going into any of the details for now. But just to highlight that the emissions from sanitation system are not so negligible. And most of the researches that has been done are done for containment systems and not for the whole sanitation value chain. So this is where the project comes in. So the project aims to estimate the greenhouse gas emissions from sanitation system in Lahan municipality. Basically, three different scenarios are considered: current scenarios, planned improvements, and climate smart improvements. So current scenario is the emissions that is occurring at present from the sanitation system. And similarly, planned improvement are the projected emissions from planned construction of the fecal sludge treatment plants. So at present, Lahan municipality doesn't have a fecal sludge treatment plant, but it is being in the design phase, and it will be implemented soon. So, third is climate smart improvement, which is all about projection of the emissions with by assuming three different criteria: increase in the coverage of the emptying population, and then increasing the frequency of emptying service, and methane capture from FSTP. Next, please. So this study was carried out in Lahan municipality, which is an intervention area for WaterAid Nepal. And there is a plan for improvement in sanitation for which we selected this municipality, and it lies in the southeastern part of the country. Next, please. So this specific study is based on IPCC method, Intergovernmental Panel for Climate Change method. And we also refer different literatures for indirect emissions as well. And there is one of the literatures that have quantified the emissions from a whole sanitation system. That is, I think Barbara is also one of the co-author in that paper, and we refer to that paper as well, Johnson et al. And the modeling technique we adopted was snapshot technique, where the emission for a specific point of time was estimated. Next, please. So, sorry. Moving to the findings from the study, so I would like to give the emissions based on the scenario. The first one was current scenario, and we can see that 40% of the containment system are emptied, but they are not taken to FSTP since the Lahan municipality doesn't have an FSTP. So they are disposed to open environment for now. So you can see the seed flow diagram for the same. Next, please. So this is the tabulated form of the summarized emissions from different units of sanitation value chain. And you can see there is direct emissions coming from containment and also from disposal. And there are indirect emissions that comes from containment system in the form of embedded carbon. And there is emission that comes from burning of the fuel by emptying trucks. So the overall emissions from current scenario was found to be to 8.71 gigagram CO2 equivalent per year. And when we say gigagram, it's thousands of tons of CO2 equivalent emissions. Next, please. So this is the second scenario, which is planned improvement. So here you can see that the 41% of the containment system that were emptied are now taken to fecal sludge treatment plant, because this is, here we assume that the fecal sludge treatment plant is in practice and all this sludge ends up in the treatment plant. Next, please. So this is the fecal sludge treatment plant that is being planned, and it consists of different units, starting from bar screen to some anaerobic digester and unplanted sludge drying beds, and similarly ending up with polishing ponds. So this is the emission profile for second scenario. We can see that the emissions from containment remain same, while there is increase in emissions from treatment facilities, and also there is increasing emissions due to indirect emissions that's coming from the facility as well. So here, after the installation of FSTP, the total emission accounts for 10.02 gigagrams CO2 equivalent per year. Next, please. So this is the third and last scenario, which is climate smart scenario. Here the sanitation system is improved by different climate smart options, which includes increasing emptying population, increase in emptying frequency, and also installation of methane capture in the fecal straw that is being planned. So next, please. So the emission profile, when the 75% of the population emptied their containment at an interval of 3 years and with 90% methane capture, the emission profiles looks like this. Now the emissions from containment system is also reduced because more people are emptying their containment and at more frequent interval. So the total emission accounts to around 7.93 gigagrams CO2 equivalent per year. So in order to compare the emissions between three scenarios, I'd like to hand over to Andres.
Thank you. So in this table, you can see all the plants, all the scenarios compared. And the first thing that is obvious is that building an FSTP in Lahan will increase emissions, but it will also increase the access to safely managed sanitation services from 29 to 70%. And I think it's very important to highlight that public health comes first. That's the main purpose of sanitation. So this is a very sensible thing to do. But actually, the more useful comparison is not between the current and the planned improvement scenario. It's more between the planned improvement scenario and the climate smart improvements, because we need to compare emissions between similar levels of public health protection. And what this comparison shows is that we can protect public health and also reduce emissions. So we see 2 gigagrams reduction in emissions between the planned improvements and the climate smart scenarios. And that's equivalent to around 700 round trip flights between Stockholm and Lahan in Nepal. So it's not negligible. And actually it's like, yeah, when looking at the emission reduction targets of Nepal is also quite significant, taking into account that Lahan is just a small town. We have also done these heat maps that helps us understand the different mitigation strategies that we were using. So these numbers in the maps are showing the change in emissions. So we are starting from this 0, that's the planned improvement scenario, so 10 gigagrams, that's 0. And then the numbers are like 2% more, or the difference between that baseline. And the green one is the climate smart scenario, so that's 8 gigagram, a 20% reduction when we have the full climate smart measures. But if we look at the measures individually, what we see is that when we don't have methane capture, increasing the population that is emptying the pit doesn't really make a difference in emissions. And if we empty more frequently, it actually increases a bit. And that's because we are just moving the sludge around, so the emissions are happening in the treatment plant instead of in the pits. So what is coming out very clearly from this study is that methane capture, in this case of Lahan, where there's an anaerobic digester in the FSTP, methane capture is the critical strategy for reducing greenhouse gas emissions. And just by introducing methane capture, we can get up to 10% reduction in emissions. But it also, when you have methane capture, the other two strategies are starting to make a difference. So you further reduce emissions if you increase the population that is emptying, and to a lesser extent, also if you increase the frequency from 5 to 3 years, you reduce the frequency at which the pits are being emptied. So what are the conclusions that we are taking from this study? I mean, first is to highlight, as Barbara was highlighting, the limitations that we are facing. So these numbers are uncertain. There are many assumptions, many simplifications, but I think that the trends or the difference between scenarios still hold. So I think this highlights that considering greenhouse gas emissions can help us see opportunities to decarbonize sanitation plants and projects. For Lahan, for instance, it's very clear that having methane capture in that treatment plant would make a big difference. But in general, low carbon treatment, be it through methane capture and ideally reuse, or at least with more aerobic processes, will help reduce emissions. And where you have this low carbon treatment option, then increasing the reach of emptying services and frequency will help further decarbonize. But it's also very important to put it in context and to understand what's the cost and the feasibility of the different options, because it might be more difficult to do one thing, more expensive, less feasible, but also consider them in the context of the co-benefits of sanitation. So maybe in one emptying more, increasing the population that is emptying, even if it didn't have mitigation effects, is really important from a public health perspective. Or increasing the emptying frequency doesn't change emissions, but it makes sense because it creates more preparedness for floods from a climate resilience perspective more broadly. And they need to be, these things need to be considered within wider sanitation plans and make sure they make sense within those. And final point is that we see there's potential of using these estimates to open up climate mitigation funding opportunities, or at least conversation. But we are also aware that these are complex processes and they need scale. They probably wouldn't make sense at the level of the municipality. Thank you.
Perfect. Thank you so much, Prativa. Thank you so much, Andres, for this amazing presentation. And thank you once again to all our speakers so far. So well, now we're gonna have a short Q&A session. So I would ask you to put your question into the comments. We also see you already have some answer there. Perfect. But you can also ask your questions directly. There was supposed to be like a ask to be unmute button, so feel free to push that button, and our great coordinators over Triples and CB will unmute you, and you will be able to ask your questions. But before we start with that, maybe allow me one little bit maybe provocative question, because I also wanted to ask our speaker if you maybe want to highlight who would be on the forefront of this adaptation and mitigation work when it comes to maybe states or organizations, international organizations. So who do you think is currently doing sort of the most? And maybe if you're feeling bold and brave enough, if you can maybe mention someone who would you like to see do more on this front? So an open question to all our speakers, if anyone wants to take the floor here.
I'm happy to say something. So I want to give a big shout out to a lot of big utility companies who do a lot of really interesting work, particularly highlighting what Andres was just saying about methane capture in treatment, where you have utilities that are really motivated to capture the energy potential from their wastewater processes. So I live in Leeds, for example. We have combined heat and power treatment, and the utility and the city that manages both wastewater and solid waste work together to recover energy, which is, a really good input. So it has an economic value to them and an environmental value to all of us. I think a lot of the larger utilities, big shout out to a lot of utilities in Brazil that have really led the way in methane capture from nature-based passive treatment systems. Some really fantastic examples there. Who would I like to see doing more? I think engineering consultants could do more to push back when they're asked to design systems. I think generally what we don't do is enough understanding of how the potential product, the emission, the gas is a product, and we're talking about it as a problem, but it's also potentially a resource. So in places where there's potential to capture that methane and use it to heat or power. I personally think that that is much better to be achieved at scale. So that I'm not talking about domestic biogas in any sense. I'm talking about what Andres and Prativa were highlighting, which is moving waste efficiently to places where we can do really efficient at scale capture of mixtures of biogas and nitrous oxide and make use of it. From an emissions point of view, actually capturing that biogas and flaring it is still better than just letting it go into the atmosphere. So even where we don't have a market, I would say we should really be thinking about changing the way we think about wastewater design.
Sam has his hand up, so Sam, please, quick comment if you have.
Yeah, just a very brief reflection. I mean, I think it's a fantastic question, František, so thank you. And building on Barbara highlighting utilities, so one comment which also provides a nice segue to tomorrow's session is also the work of regulatory authorities who are looking at what is involved in standards to support climate resilient sanitation, because for utilities to be able to co-opt these standards and mainstream climate resilient sanitation into their operations and service delivery, they also need to be supported, of course, at the policy level, and at the regulatory level. And there are examples of regulators, and you'll hear from Angela Kimani at WASREB in Kenya tomorrow about how they have worked to develop those standards, and others, particularly in Eastern and Southern Africa, which is WASREB's vantage point. We have programs in that region, and we're seeing regulators engaging with this challenge, but also more broadly regulators like ERSA in Portugal, SISS in Chile come to mind. You could pick your region. They're regulators that are looking closely at this. And then in terms of what more could be done, or who I would like to see doing more, I won't pick on anyone specific, but maybe it's a slight caveat to my own presentation, where I say that the evidence base, I presented that as quite strong around adaptation, but in fact there's a lot more research that could be done to strengthen the empirical evidence around these adaptations. There is a very solid logic to many of the interventions that we present as being climate resilient, but there is more that I think particularly implementing organisations as well as funders can do to support action research. Any climate resilient sanitation intervention, for example, I still think at this point in time we should be looking to attach research onto that, attach data collection and evidence generation, so that we're able to make an even stronger case than we have now.
Perfect. Thank you so much, Sam. John also has his hand up, so also please just a quick reflection so we can get one question from the audience.
Yeah, thanks very much. I would also like to see financiers and in particular insurance companies and insurers getting more engaged with the importance of this topic, because they have much more power over the organizations that are implementing sanitation than the rest of us do put together. Thanks.
Perfect. Thank you so much, John. So now I would really like to give floor to the audience. If anyone from the audience wants to ask a question directly, so please click that unmute button, and Linnea, our lovely support over at Triplets, will be able to unmute you and you'll be asked directly. So do we have any volunteer? If not, then we're going to go into the chat. I see a message down here from Salma. I have a question, please. What are the most cost-effective technologies currently available for methane capture in waste management systems? And how scalable are these solutions for cities with limited financial or technical capacity? So Barbara wants to take that one.
Barbara, over to you.
Yeah, so first of all, I mean, there are technologies around. I mean, capturing methane, well, capturing biogas isn't that technically difficult. If you have the capability to run a good wastewater treatment plant, you certainly have the capability to capture methane. In terms of finances, if you do it well, it's going to be, I mean, if you're really lucky and smart, it's going to be net positive for you financially, because you can recover the value of that gas for generating heat or power to improve your process. Can it be done if you don't have technical capacity? Absolutely not. and neither can sanitation. And I'm really sorry, but we have to stop saying that sanitation, in my view, we have to stop saying that sanitation is something that can be done without technical capacity. We do need to invest in good quality process engineers and civil engineers and technical people who can run these systems well, and there's no getting around that. My analogy is neither can we do brain surgery without really well qualified brain surgeons. You know, we kind of, this is really important, but I would argue that it's almost like we do ourselves a disservice when we're seeking these kind of like skill-free services. Some of the smartest I think this question came from Tunisia, and I have to say some of my smartest colleagues are Tunisian, so it's not for lack of capability. What we need to do is to make it into a really kind of cool job that people want to do, running climate smart sanitation systems in Tunisian cities. Sorry, just muting.
Perfect. Thank you so much, Farah, for this answer. Unfortunately, we need to move on. But if you have any further questions, just put them into the chat. Specifically, if you have for any specific speaker, we'll make sure to pass them on to them. So now I would like to invite our next, basically final speaker, final presentation, which is Kate Medlicott from WHO. Kate, you mentioned that you will present your presentation yourself as well, so please feel free to share your screen, and the floor is yours.
Wonderful. You can see that?
No, not yet.
Okay, maybe now.
It's coming up, yes.
Great. Yeah, so you've heard, as we've been speaking, about the Climate Resilient Sanitation Coalition for Action. So my task here is really to give you a quick overview of the coalition and get you kind of excited to join and hear some of the achievements. Just in terms of the coalition itself, we have a whole range of partners that are involved, and you'll see there, you know, from funders to academic institutions, UN organizations, banks, private sector, and so forth. So it's a really broad coalition that's allowed us to really move quite quickly in a short space of time to advance the evidence and action and visibility of this issue. I should actually give a shout out especially to Nat Painter of UNICEF, who's been doing a wonderful job of convening us regularly, along with Juliet Willits at UTS. But our task is really this. So it's a bidirectional approach of trying to make sure that sanitation is well represented within the climate sector, which historically it has really not been, and we've made progress there, but still plenty to be made. And similarly, to really get climate well embedded within the sanitation sector, with these three kind of main things we've been working on, which is increasing access to climate finance. You'll hear a bit about the GCF annex. Increasing the prominence of sanitation and climate policy, particularly through, you know, the big COP events and so forth, and then also building capacity at the national level and making sure we've got good learning loops back to the partners so that we can all learn and move faster. So I just wanted to go into some of the progress we've made over the last 3 to 4 years, focusing on the major COPs. So the first was at COP27 in Egypt, where we launched the call to action on climate resilient sanitation. That was around events at the Water Pavilion and the launch of the Climate Resilient Sanitation Coalition. And that really allowed us to come together as a sector with clear messaging and direction. But of course, that's not enough. You have to go much further within these COPs to be really effective. So in the next year, what we saw in UAE was the framework for a global climate resilience definition and towards climate resilient sanitation, and also the global goal on adaptation, which included a target for climate resilient WASH. The next year, we see the launch of the GCF annex and the definition of climate resilient WASH services. And now, as we're looking to COP30 in Brazil, there's really a focus on implementation. So how sanitation is integrated into the NAPs and NDCs, and also the lessons from that implementation. And again, we're starting to see the number of countries where sanitation is included in those national plans rising. Turning now to the GCF Annex, which was the major achievement of last year. So this is from the Green Climate Fund, a very clear sectoral guide developed with GCF as well as many members of the coalition contributing to the chapters that really talks about a lot of what you've heard today. So the climate rationale in terms of adaptation as well as mitigation, and also some clarity around potential interventions for adaptation and mitigation, but a really strong focus as well on system strengthening to enable climate resilient sanitation, and then some very clear step-by-step guidance about how to develop a GCF proposal. So this is our big hurdle now, is to increase the number of high-quality GCF proposals on climate resilient sanitation. I'm going to pivot now to show you a short video. There's a lot of detail inside the annex itself, but if you're wanting to get all of this across quickly to a kind of a lay audience, then I would encourage you to share this video, which we'll put in the chat. Okay, oh, we're stuck. Okay, and then finally, just to say, please do follow the QR code to find out a lot more about the coalition. Thanks.
Perfect. Thank you so much. Thank you so much, Kate. So we are at the end of our session. So before I give the floor to Fabiana Bianchi from the Latin American Development Bank of Latin America and the Caribbean, I just want to again remind everyone that this is a part of a three-part seminar. So there is another session that is online and on-site tomorrow at 2 p.m. Stockholm time. So if you're on site, please come find us at the room that I just forgot. Oh yeah, it's the room C1 at level 2. Or if you online on the link that you should have received, or if you register, you will receive. And there's another session on Wednesday at 11 a.m. So now over to Fabiana to take us out.
Thanks.
Thank you.
Thanks, fantastic. Thanks. Good morning and good afternoon to everyone. It's a true pleasure for me on behalf of CAF, Development Bank of Latin America and the Caribbean, to deliver the closing remarks for this important event held within the framework of World Water Week in Stockholm, which we have had the pleasure to co-organize alongside WaterAid and WSAP. I would like to extend special thanks to each speaker for the valuable contributions shared with us today. We have heard science-based evidence showing that sanitation is not just basic service, but also highlighting the importance of integrating sanitation with climate action. The discussions highlighted how extreme weather events impact sanitation systems and also how resilient design can transform these systems into key solutions for both climate adaptation and mitigation. In a very brief summary, I would like to highlight some central messages from this session. John Lane clearly reaffirmed that science shows the importance of integrating sanitation into climate action. Sam Drabble showed us how sanitation and the climate cycle are closely interconnected and how adaptation in this sector can generate transformative impact across other sectors. Professor Barbara Evans shared cutting-edge science on greenhouse gas emissions linked to sanitation, highlighting that sanitation requires technical capacity, even more so if we want to work on climate-resilient sanitation. There is very high potential, but training is required. From Nepal, Prativa Baudel and Andres Hueso presented a concrete case in Lahan, illustrating the opportunity for decarbonizing sanitation projects based on emission estimations. Finally, Kate Medlicott introduced us to the work of Climate Resilient Sanitation Coalition, highlighting the coalition's priority actions and achievement in building shared global vision. This was the first of 3 sessions of the seminar Climate Change Mitigation and Adaptation through Sanitation Systems. Today, we focus on scientific evidence. Tomorrow, in a hybrid format, we will explore real-world examples of climate-resilient sanitation projects and how to scale them up. And on Wednesdays, we will discuss in Stockholm how to mobilize great financial resource for this purpose. We hope you will join us throughout this journey. We trust that this space has strengthened the understanding of sanitation as an important pillar of climate strategy solutions that improve the lives of millions of people around the world. At CAF, we are convinced and actively moving forward in expanding our interventions in sanitation with a resilience approach, both in our operation and in technical assistance. Sanitation must be resilient throughout its entire cycle, from collection or storage to final disposal, as well as in its contribution to reducing greenhouse gas emissions. To close, I would like to thank all of you for your participation and invite you to join the upcoming session of the seminar. Thank you very much.
Thank you so much, Fabiana. Thank you, everyone. This is the conclusion of our session. Thank you and hope to see you tomorrow and on Wednesday.
Thank you.